my screen. Hopefully you can all hear me and you can see the screen that I've got on here now. So what I might do is move my camera over, then I'll actually talking to you whilst doing it. I think it's a bit confusing on dual screens here. Novel approaches to surveying invasive species, aka using drones essentially for this. And I've got a sort of little set of slides here, which we will hopefully get through in the time. Just a little bit of background about drones, the uses of them. Just for those that don't know, most people will probably know, but there's some information there anyway. Then I've got some background of a study that I did as part of my PhD. It was one of my potential PhD sort of projects. It wasn't completely finished, and it was back in 2015, but it sort of shows the utility of where these things could be used, some future research aims, and then also sort of how things have changed since 2015, because obviously it's 5 years ago now, or maybe 6 years ago now. So yeah. So what is a drone? It's basically an aircraft or aircraft system, which is flown from remote location without a pilot. Obviously, a lot of these things come from military in the first place, and you've got a couple of examples there of a very large combat drone, and then also an extremely small combat drone, this black corner here. You can see where the technology could get to with a little tiny little aircraft like that. That's kind of where everything is kind of going eventually. Lots of different acronyms: UAV, unmanned aerial vehicle; UAS, unmanned aircraft system; RPAS is the current term that people like to use. Just to try and get away from the sort of the drone connotation because of the military aspect that's usually behind that. Types of drones. So multi-rotor drones is what's probably most people are familiar with. The DJI Phantom up there is probably a particularly common one. Really good, nice and stable, easy to take off and land, vertical takeoff and landing, easy to control. The only downside of these is their endurance. It's getting better, but generally the endurance is, for typical modern day ones, 20 to 30 minutes, somewhere around that mark. So not particularly efficient. And you will see larger ones. So you will see like quadcopters, or ones with 4 rotors or 4 motors rather, are the standard, but you also see 6 and 8 and 12. And basically, they all fly exactly the same way, but the more rotors you put on it, there's more capacity, the more payload it can carry, and the more redundancy you get. So you're putting particularly expensive sensors on there, then you might want to have more rotors just to be a little bit safer in the sense of any issues that might occur. You also get fixed-wing drones as well, basically planes, small planes. And these have got a number of advantages and disadvantages. The main advantages being the fact that there's usually only 1 motor or maybe 2. You've got a large wing surface, so you can fly for a much longer period of time. But the downside is mechanically slightly more complicated because you've got ailerons and elevators and things like that going on there, and a lot more difficult to control. So for sort of a novice user, it's a bit more of a steeper learning curve. Also come in different sizes. Small ones you can hand launch. Larger ones require things like catapult launchers to get them going. So it can be a bit more difficult to use in the field. But they do have their advantages, mostly because of that endurance. Helicopters are another option as well. You don't see them so much. Again, mechanically more complicated, but they're a bit more efficient. Generally, you see them in larger sized UAVs, which is a precision sprayer there. And hybrids are also one which you're going to see more of those. I think they're going to become the more dominant type, a mixture basically between a multi-rotor and a fixed wing. Example there, an early Amazon one, but you're seeing quite a few more of them come out, and they're getting better and better. You get a best of both worlds in some ways, with the vertical takeoff, hovering capacity, but also the endurance in horizontal flight. You get a whole range of other things: blimps, powered, gliders, parasails. There's a whole range of potential options. Advantages. So main advantage really is the cost. As once you own one of these things, you can essentially collect data whenever you want, whenever the weather is good. You can go out there, you can collect information, and it's very high resolution, so it can be quite useful for detecting what species you're looking at. And also you can operate things like under cloud cover, so where manned aircraft and satellites basically won't see anything. because it's cloudy, like a day like today, which is a nice day. I can see out there, but it's just got a thick level of cloud, so I won't see anything on satellite imagery. We can fly underneath that, so you can still collect data. And that gives you high temporal availability. So if you're wanting to do quick turnarounds, or even not necessarily quick, but continuous missions basically of the same area, maybe once a week or once every few months or something like that, you can do those repeat surveys, with relative ease, and also low cost. Once you've got the aircraft, you can just keep on flying it basically. Disadvantages, of course, there's always going to be disadvantages. Generally, the sensors that are on them, whether they're cameras or like a more complicated multispectral sensor or something like that, are going to be less complex than you'd get on a plane or on a satellite. More susceptible to things like high winds and adverse weather. So you do have to kind of pick, obviously rain generally precludes flight completely. And with wind, if it's getting up beyond 5 meters per second, you want to think twice about flying. And definitely if it gets above 10 meters per second, you don't want to be flying at all. The area that you cover is also smaller compared to satellites and manned aircraft. So you just have to do more repeat flights. It depends on the area you want to look at as to what choice you want to make on the aircraft type or even platform that you use. And if you are recording kind of larger areas, you've got quite a lot of data to process, so you can end up getting a bit data heavy depending on the size of area you're looking at. So that's a little run through of drones. So this is a little bit talk about the actual project that I was looking at, and I was particularly interested in giant hogweed, mainly because it's a little bit of a cheat. It's slightly easier to pick out than some of the other sort of top three, as it were, invasive species or typical invasive species in the UK. And obviously with giant hogweed, you've got dense stands, it's a tall plant, wide leaves, and it produces a large amount of seed. I mean, the value I've got there, 20 to 100,000, there's a lot of flex in that. It could be 1,000 to 20,000, but generally a lot of seeds gets produced, and that seed will stay in the seed bank for quite some time. So the main sort of aims of this particular project were to just basically using drones. Is it practical? Is it a practical tool for surveying giant hogweed? And then at the particular site that I was looking at, a place called Manor Palace, what was the spatial extent of the infestation that was there? The cameras I was using, I'll put this up just because it might be of interest to some. So I did a bit of a hack job on a couple of old point and shoot cameras. So I've got a sort of a cheap multispectral camera, cheap being about less than 100 quid for the camera setup. And it worked relatively well. And it's something that might be of interest if people want to get into multispectral imagery and things like that, is a cheap route in rather than buying an expensive camera. The drone I used was too large. This happened to be the development aircraft that I had for a lot of different reasons, so it got used for this, but it's quite a big beast. Octocopter, so vertical takeoff and landing. Flight time, not that great, 10 to 15 minutes, the setup that I had. But flying at sort of the highest altitude that was legal, I could get a sort of approximately 10 hectares per flight. So he just did swap batteries to pick out if you're going over a bigger area. This is the actual study site itself, a place called Manor Palace, which is it's basically cut halfway down between Stirling and Clackmannanshire Council. Brownfield site was a coal mine being rather. Then it was a tip at some point, a municipal tip, which is probably how giant hogweed got in there in the first place. And it's been used as a 4x4 circuit on and off, which has probably helped to spread the species around. It's bounded by Alloa Stirling Railway to the north, and then North River Forth itself to the south. And what part of the project I was going to be looking into identifying seed source, how much seed source will get created, how much could spread into those transport mechanisms. Unfortunately, I didn't get that far. That's in the future research bit. Here are data collection. So for the actual research I did, I only used one data set, which is the first one, which is in flowering phase back in July 2015. But I took several other surveys since then, which I'm hopefully going to use that data at some point. And I've actually done more data since then as well, actually. You notice here the slightly strange image that we've got here is because when you're surveying with the drone, you're not just simply flying as high as you can to get one picture of the ground. We want to collect a large number of overlapping imagery, which we can then process into what's called an orthomosaic. So we create a map of what's on the ground. So you can see that for this survey, which is done with basically 2 flights, actually captured 141 images across the whole site. And this is all automatic, so this is not manual flight. This is me programming the drone to say, go fly backwards and forwards, collecting this data as it goes, and it goes and does it itself. And here's an example of one of the mosaics. So I haven't got to like what the processing and things that I've done on that, and we can discuss that later if people are interested in that sort of thing. But I used a program called Digital Photoscan, which is actually now called Metashape, but it's one of a suite of different programs which can do this kind of thing. And I used 16 ground control points, which were marked up with a high accuracy GPS system to make sure it's spatially oriented. And we can see straight away, this is obviously just a color image, but we can see straight away we've got these large patches, large stands, a giant hogweed, pretty infested across the board, really. And also in the flowering phase, quite nice and easy. You can see this big dinner plate sized inflorescences that are on there. And I've also got a false color orthomosaic as well. So this is using the near infrared information from the modified camera that I've got on the drone. And this is very useful for doing thresholding, separating. So if you're trying to do automatic classification, get a computer basically to tell you what things are in the scene, having this extra spectral element is useful because it's very good at being able to differentiate between what is and what is not vegetation as a starting point. And again, we can still see with this, we can see those large stands fairly clearly as a sort of a lightish pink to white color. And this is the other interesting thing as well, is that when you're using drones in this way, in doing surveys and mapping in this way, you get a freebie element, which is elevation models. So you can start seeing structure of vegetation, which is, again, incredibly handy, depending on the species you're looking at. But something like giant hogweed, which is a tall species, we can use that as part of the classification routine. So this is what's called a surface model. So this is elevation of everything that's on the surface, trees, buildings, anything that's there. We can do a bit of interpolation to get a terrain model, so we can try and strip out the vegetation and the buildings, just try and get what the ground surface is. This is not 100% accurate. There's a lot of fudging going on in here, but it is reasonable, and we can then use that basically along with the DSM. We can minus the DTM from the DSM, and we end up with a vegetation height model. So we can see the surface of the ground and then the height of the various bits of vegetation that are there. Which again, pretty useful. And again, we can see those big stands of vegetation that are in there over to the sort of the west and the central portion. We can see them fairly clearly. So we can use all that. We can take all that information in and we can run it through a classification program. And I use an open source one called InterImage, which is actually an object-based image classifier. Not the best. It is free though, which is good, but it can't handle large amounts of imagery. So I actually had to split my scene up into lots of little individual squares, which is not a good way of doing it. I ran it through various different algorithms to basically threshold to separate out the classes that are there to try and bring out, where is the giant hogweed in this area. And we can use the height data, for instance, very useful for picking out things like the trees and the hogweed itself. And because of the way object-based image analysis works, we can actually do analysis based on other classes. So for instance, it was very easy to pick out where the flowers were, big white things, really easy to pick out. So if we were less sure about the vegetation, for instance, around those flowers, we could say that if they're within a certain radius of the flower, within say a meter or half a meter, we can then say, well, that's most likely giant hogweed vegetation. So we can use the information to basically build up the classification routine. And this is the classification that I managed to produce, which is pretty good. You see the pink there with the trees and the sort of the light greeny colors and the white there for the giant hogweed. And it is not too bad. I'll come on to the accuracy in a minute, but there are some errors. Basically everything that's north of the train line there at the top in that field actually isn't giant hogweed. It's actually some form of creeping buttercup, ranunculus. So there's definitely there's improvements to be made. Just there wasn't that much of that actually in the area that I was looking at, so that didn't get picked up until sort of post analysis. The picture accuracy itself was about 85% with a kappa stat of 7.71. But the accuracy for the actual hogweed class thing I was interested in was actually below 70. It was around 68%. So there's generally like a cutoff where you can say, is your classification accurate enough? And at the moment, it isn't. It needs a little bit of work. But there's quite a few things we can do to fix that. Some of the obvious areas we can try and fix. Some of the height errors. Also, I said a bit of fudging going on there with the creation of the GTM. and also image block areas as well, just because of the way I had to split things up. It makes for a harder classification. You can sort of see that in this image down here, where you've got this this pink tree has a very flat side on the east there. On the east side is very flat. That's because that's where one of the image blocks was cut in half. So it causes some issues. Just to get an idea of the distribution, and this is versus a study that was done by BugLife in 2013. They weren't actually looking at giant hogweed. They were looking at various places around Stirlingshire for invertebrate species, but they did do some classification of vegetation, and at this site they did do a sort of a preliminary analysis of giant hogweed distribution, especially the dense stands. So we can see that where I'm picking up large amounts of giant hogweed in the orange there, they are kind of matching up fairly well with the dense stands that were back in 2013, although I am picking up considerably more. So there was areas where it's either it has increased or their survey just didn't cover it, especially down towards the south there. They might have looked down in that area. So conclusions. They are effective for surveying areas, certainly for surveying small areas, doing site-specific surveys and things like that. Going over larger areas, so thinking about if you're doing surveying along river systems, which is quite often very common, especially for giant hogweed, then you might want to think about perhaps using something like a fixed-wing drone where you get more endurance that you can monitor as you go along. The actual processing chain I used was a bit long-winded, needs to be improved, but a lot of it is automated, so it's not too bad. I'd like to be able to see more just the use of standard RGB cameras, and I have actually done some work with that with master's students, looking at the differences. We haven't quite finalised that yet, and I'm hoping to get more master's students in this year actually as well to look at some more elements of research. But if we can get away from relying, or not relying, but wanting to use multispectral, to using bog standard cameras that are ubiquitous on modern drones, then that would also be an advantage. The interesting thing was small plants could be picked out, so less than sort of half a meter jobbies, and that could be particularly useful from a management perspective if you wanted to be able to give an accurate map to your contractors before they're going to go and do any work. Then being able to map before that work continues, just at their sort of cabbage stage, as they're kind of just coming out and are smaller, then that could be useful. And there's also links potentially in how we could use this with things like automated spraying of drones in the future. Obviously there's various regulations around that. It's not actually legal at all at the moment, but when it does become legal, you could see these two technologies matching up. So further research that I want to look at is use of satellite data, Centaur-2, which is the free satellite data we can get from European Space Agency, but also Planet Labs as well, which are these one of the constellations of these smaller micro satellites, which are higher resolution. So I want to have a little look at being able to use that, maybe in conjunction with upscaling from drone imagery and seeing how we can expand it across. And also phenological changes as well. There's various researchers that have looked into this, ways of marrying up multiple surveys done at slightly different times of year, and not just for this species as well. So Japanese knotweed was one which was seen as being an easier one to survey if you have surveys at different times of year, because you can see different phenological changes, stages of the plant, and you can use that information layered up to give you a better classification result on more exactly on what is where. So that's another area to look at as well. This is what I wanted to continue on with my research, which was looking at seed source creation and trying to estimate how much seed gets created from whatever the problem is that you have to deal with. And that's something I'm going to look at a little bit more, whether I can work out, I can identify what is a plant away from the big dents, how many plants are within that big dent stand, or just how many umbels are in there, and then try and work out from that how much seed is being created and therefore how far it could spread, etc. I think I'm doing okay on time. So how have things changed? So drone regulations have changed a fair bit, actually. New regulations come in this year in 2021. And they've changed from a commercial, non-commercial split to a risk-based model, which I think is a good thing. There's a lot of comment on whether it's good or not, but I personally think it's a good thing because it allows more not researchers, but operators to work in this space and work with drones. So, with less cost, basically, because the older certification schemes were fairly expensive, a bit time consuming. So you had to put in a bit of effort to actually get a qualification to use them commercially. Now it's less so, and if you're in a low risk area, you don't actually need any certification at all. There is one out there called A2 Certificate of Competence, which if you're thinking you're going to be working anywhere near any kind of urban area, or maybe where there's members of the public and things like that, where you've got a higher risk of the drone operation, then that's probably the one to go for, and it's not particularly expensive. So it's around 140, 150 pounds. And it lasts for about 5 years, so it's worth looking at. The drones themselves, they're much better nowadays than they were, and much cheaper as well. I've got an example there of a Parrot and Naffy, which is just one particular example. I quite like this particular drone purely because it's very lightweight, which means you can use it essentially very close into people. The camera on it is pretty good as well, and it comes in between 500 to 1,000 pounds. But there's others out there. There's various DJI ones and things as well within that same sort of bracket as well. Some are slightly heavier, so they're less able to be used in high risk areas. So it's worth looking at what kind of size of drone related to what area you want to use it, what level of risk you're going to be using it in. Software to enable these kind of surveys is again typically free or very low cost. I've got a couple of examples there: Pixel Capture and Lychee. And this is mostly for off-the-shelf drones. If you're into building your own kind of drones, you'd be using something like Mission Planner for Pixel controllers and things like that. But yeah, most of the time people are buying one off the shelf, so you need to use something which is compatible with your tablet and your iPhone. Software that processes drone imagery itself. Okay, I've got like 2 slides left, so it should be good. The software to process drone imagery itself, it is still fairly expensive. There are some cheaper options. So if you're wanting to do this, although you could have the drone, have the software to collect the imagery, when you come to actually wanting to process it, it's still going to cost a little bit of money to do that. Pixel Mapper is one example. Can be done on a monthly basis, but it's still quite expensive. You're still looking at probably 100, 150 pounds for 1 month's license, as it were. Open Drone Map, I've never actually used Open Drone Map, but it looks to be a lot cheaper. I think it's about £100 for, I think, a year, which is pretty good if it's effective, which it probably is, because most open source stuff is getting better and better nowadays. Then for the actual mapping and things like that, I expect most of you have probably come across QGIS. Definitely, if you haven't come across QGIS, just download it. It's free, it's good. And also, I've been playing around with this little application called Input with my ecological survey students, which allows you to use QGIS in the field for collecting data. Really handy and free. Definitely worth looking there as well. The classification itself, that still requires expertise. There isn't an algorithm that I know of at the moment where you can basically just go and borrow that algorithm and run it against your data. So that would still require some expert knowledge, but it can be done within QGIS itself. And there is actually some interesting stuff that I've seen out there to do with artificial intelligence as well, and machine learning algorithms. I know CEH have been doing some work on it, so it's possible that in the future there may well be ways where you could put your imagery through some small online scheme which will automatically tell you what it is. So that could be an interesting thing coming through. So would drones be useful for other species? It's does rather depend on what they are. So Japanese knotweed, I know, is a viable thing because other researchers have looked at it. Himalayan balsam, I think, would be more difficult. There's some papers I've seen out there on it, just simply because it's similar to other things. So it all depends really on how effectively it can be separated from native vegetation, and if it has any particular traits that make it stand out in any kind of way. Does it speed up monitoring? I've said potentially there. It does depend on how you're doing the classification, because if you're going to be doing it manually, you're still going to be spending time poring over an image and drawing polygons around where you think the infestation is. And as already mentioned there, artificial intelligence, machine learning is potentially a promising aspect to this as well. But generally, it will always widen your survey area. So you'll always see a little bit more area than you would be just from the ground, with the same kind of similar effort put into it. And other uses, if you wanted to do PR, if you wanted to highlight the problem, things like that, drones are great for doing 3D video, and you can also do 3D models as well, which I can show folks in a bit, a little example of a 3D model. And then before and after comparisons as well. I know, for instance, colleagues at Forth Fisheries Trust did this quite a few years ago now, where they could do a quick survey before and then they get the contractors in to do some work and they do a survey afterwards, just to check up that have they actually done the work they were supposed to do in the area they were supposed to do it. So that's it. Any questions on that?